In this video, I'm going to be talking you through a little bit more of the theoretical side of some basic descriptive statistics. For more advanced users, this may not be new information to you, but the practical may be. So we would encourage you to skip ahead then to one of the future videos where Chris will demonstrate how to do some of these statistics in Excel and how to interpret these statistics in a practical application using your education data. In this session, what we're going to be doing is looking at statistics that describe our typical data, so the mean and the median, and then also looking at ways we can summarize our data to know how the data is spread out, so how far apart it is. And specifically, we'll be looking at the minimum, the maximum, and also its standard deviation. So the mean is just a fancy way of saying the average. And in order to get this, we take all of our values, we add them together, and we divide by the total number of observations that we have. So for example, if we have a class where we have 10 marks, and these are the marks listed here, in order to work out the average value, we just add all of those together, we divide by 10, which is the number of observations, and we get that our mean mark is 52.8. Where this is useful is we can summarize our data and get the average performance or the mean for various schools, for example, and look at a question like which school had the worst mathematics performance. So school A had an average mark of 52.8, B 55.3, and C 49.7. And just from this information, without having to look at the data itself and all of the individual marks, we can guess that school C had the worst performance, 49.7, which is the lowest value. Something else that is useful to know is what we call the median, which is the value in the middle of our data. Or another way of saying this, it's the value that half of our observations are below that value and half of the observations lie above that value. If we have an odd number of observations in our data, then there is a value which is directly in the middle. So if we have 3 bits of information, for example, 1, 2, and 3, there will be 2, which is in the middle, and that does exist. But if we have an even number of observations, there isn't one value which has half of the other values above it or below it. So in that case, we just take the average of the 2 middlemost values. Turning back to our example with the marks, the first step that we want to do when we want to look at the median is we want to order the marks from smallest to largest. And then what we can do, so here we have 10 marks. That's an even number, so we want to look at the 2 middle values, which in this case is 33 and 55. And we then want to take the average of this, so 33 plus 55 divided by 2, and we get that the median for this data is 44. What that tells us is that half of our observations lie below 44, and we can check that for ourselves if you draw a line over here. 5 of our values are below 44, and 5 of our marks are above that. So where the mean and the median are useful is it gives you a quick summary or a quick little bit of information about our data. Here, our average mark is 52.8, and the median, so half of the values lie above and half of them lie below a value of 44. If we use now mean and median together, we might have a situation where we have the mean and the median mark for various schools, and we want to decide which school is in need of a mathematics intervention which is targeted at low-performing learners. These are the same fictitious schools that we used in the previous example. So school C still has the lowest mean mark. But now if we look at the median, you can see that it's actually school A which has the lowest median mark. So in school A, half of the learners got a mark of 44 or less, whereas in school C, half of the learners got a mark above 49.5. So we might argue, based on this information, that school A would be the school which most needs an intervention targeted at low-performing learners, which would be different to the answer that we'd get if we only looked at the mean. The more information we have, the better it is, and we can make better informed decisions. So even though this is useful, it doesn't necessarily tell us how the marks are distributed or where they lie. So we know that half of the marks in school A, for example, are less than 44, but we don't know how much less than 44 they are. This is where we want to start to look at some additional information which tells us about the spread of data. So I said at the start that the mean and the median give you the information on the middle or your typical data, but they can also hide important information about the higher marks or the low marks or what's happening. And just as a simple example here, let's say that we have these three schools where each number here is marks. In school D, every single learner just got a mark of 5. In school E, we have 2, 4, 5, 5, 9. And for F, we have 3, 4, 5, 6, 7. You can see quite clearly that these are different. I don't think anyone would argue about that. But if we are only showing the mean and the median, they have exactly the same mean and median. All of them, and you can go and check with the calculations yourself, all of them have a mean and a median of 5. So if we were basing it on that, we would think that the data is exactly the same. But as you can clearly see, it's not. So there are a couple of things that we can look at which can give us an idea of how the data does vary. And this is what I'm talking about when I'm talking about the spread. So one simple, quick thing to do is to look at the maximum and the minimum values, or the highest and the lowest values in your data set. So in this example, for D, the maximum and the minimum, they're both 5. This data isn't spread out at all. Everything is 5. For E, the minimum is 2, the maximum is 9. So we can see there's a bigger range. It's more spread out, or relatively high spread. Whereas for F, the minimum is 3, the maximum is 7. So there is some spread. It's more spread out than D, but it's less spread out than E. The minimum and maximum are useful in telling us what the highest and lowest values are, but it also doesn't tell us how many are close to those values. So it's possible you might have an outlier. Let's say you have that everyone in the school is getting a mark of about 60%, and then you have one person who's getting 90%. You might think by just looking at the maximum that that school has a lot of high achievers because it doesn't give you extra information. So something else that we can look at, which is less sensitive to extreme values in our data, is the standard deviation. So the standard deviation, it's a numerical measure of how spread out our data is from mean. And the way this is calculated is that it's the square root of the variance. And the variance is essentially the average of the squared differences between each data point and the mean. You can go and look up the formula for yourself. What I'm going to explain in the rest of the session is the intuitive explanation behind how variance is calculated and how we move from that to the standard deviation. So let's say we have, this is now for another fictitious school, we have this set of marks for a test. Each number over here represents a mark that a student achieved. And what we can do is we can work out the mean for this. So the mean, you can go and check, is equal to 40. And we can plot each data point as it exists. So the first one was 46, it's over there. The second one, 37. And we can work out for each point, how far is it away from the mean? So the distance away from the mean. Or in other words, the deviation. So for this first point, it's 46, so a mark of 46. That is 6 marks away from the mean of 40. The next point, which is 37, is 3 marks away from the mean of 40, but it's -3, right? It's below. And we can go and work this out for each and every single mark that we have in the data and work out the distance from the mean, or the distance from the line, essentially. And we can then square all of these and add them together, as shown here. The reason for squaring is so that they don't cancel each other out, because if we had, let's say, this -7 and the 7, and we just added these up together, they would cancel each other out and it would make it look as though the data doesn't vary at all when actually it does. So to get to our variance, square each deviation, add them all together to get this 224. Then we divide by n-1. It's something you don't have to worry about, but it's a sampling correction to get to our average. So we have 10 marks, so we divide by 10-1, or 9, and we get 24.9, which is the variance. This variance of 24.9, though, in the calculation, it was worked out by squaring things. So the unit of measurement for variance is therefore units squared, which is confusing to work with. If I tell you that the data varies by 24.9 marks squared, what is a mark squared? It's quite confusing, which is why we find it easier to generally just work with what we call the standard deviation, which is the square root of the variance. So we could take the square root of 24.9, we get 4.99. So for this data, our data essentially varies by 4.99 marks. That is almost, you can think of it like how far it is on average or how close it is to the mean. When we interpret standard deviation, the value itself is interpreted relative to other values. In general, what you can remember is that a higher value means that the data is further away from the mean, so it's more spread out. If there's a lower value, that means that the data is closer to the mean, so it's less spread out. And when I say that it's relative, what I mean there is that whether it is low or it's high, it depends on what we are measuring and the mean of our data. So if we have a standard deviation of 10 and we're measuring annual school spending in rands, that's going to be quite a small variation because annual school spending is in the hundreds of thousands or million of rands, so 10 isn't that big. If we're talking about the standard deviation of the mathematics mark out of 100 in a class, then 10 is a little bit more variance, right? Because 10 is closer to a mark out of 100 than it is to something out of hundreds of thousands. Or if we're working with teacher absenteeism, so the number of days that a teacher is absent in a term, we wouldn't expect that to be a very, very high number. So 10 relative to that average would be quite a lot of variation. Practically, where we might want to look at this or where it can help us to get more information is we can go back to the example with the schools. So it's the same mean marks that we had earlier, the same median marks, where we said that school C had the lowest average mark. School A, though, probably had the highest number of lower achievers because the median was 44, so half of the learners achieved less than 44. And now we have the standard deviation for these three schools. And maybe we're trying to figure out which of these schools would benefit most from a mathematics intervention that is targeted at learners who achieve less than 30%. If we look at school A, the mean mark is 52.8, and the standard deviation is 29.63. This tells us, relative to the mean, 29 compared to 52 is quite a big number. So it's telling us it varies quite a lot. So we might have some learners in the school who have 53 plus roughly 30, so who are achieving in the 80s. But we probably also have some learners then who vary from the mean on the other side, so they're very low, 52 minus 30. So we get into the 20%. So school A probably has quite a lot of learners who achieve less than 30% or poor achievers. School B didn't come up in either of our previous questions because they have a high mean maths mark of 55.3. Their median is quite high as well, so half of their learners are achieving more than 57.5%. But you see they have quite a big standard deviation, so the standard deviation is 21. What this is telling us is that even though the school has a high mean mark and quite a high median, there's a chance that there might be some lower achievers here because 55 minus 21, it's in the 30s. So there might be some learners who are doing quite poorly. School C, on the other hand, had the lower mean math mark, so less than 50 for their average mark. Half of their learners are also achieving less than 49.5. But if we look at the standard deviation, do you see it's much smaller than the previous two schools? What this is telling us is that even though the mean and the median are relatively low, all of the marks are quite close to that. Let's say with it like +6, -6 of those values, it doesn't vary by that much. So that might tell us that there are not actually that many learners who are achieving about 30%. Based on this information, school A is probably going to be the school that will have the most learners achieving less than 30%. And I can show you it is fake data that this is based upon for the three schools. So these are the 10 marks used to construct the mean, median, and the standard deviation, which are shown in the previous table. And you can go through and check that all of these statistics do line up with what you would have expected and what we discussed on the relevant slides. So school A, you can see with its high standard deviation and its low median, a lot of the learners are achieving very low and very poorly. But their average is dragged up because they have some high achievers as well. School B does have, on average, good achievement, but as we saw with the standard deviation, the high standard deviation, there were also some lower achievers in that school. And school C, you can see that everyone is fairly close together. So it ranges from 40 as a minimum to 62 as a maximum. Not a lot of variance, but there is still some lower achievement. Okay, so That's the intuition and the simple theory behind some of these summary statistics, which make it useful that rather than looking at our data, which in this case was simple because we only had 10 learners and we could just eyeball the data, but it gets a lot more complicated if you're looking at hundreds or thousands of learners, or even millions of learners if you're looking nationally. So summary statistics give us a quick way to simply get an idea of what might be happening with our data. So what we've done in this session is look at the intuition and how to calculate some of these simple statistics. Usually what we do is we calculate this in Excel using pivot tables, and we are going to demonstrate this in one of the upcoming videos.